All right, guys, we're going to talk a little bit about conditional statements. This is our first lesson of the new unit on reasoning and proofs. Okay, so the conditional statement is a statement that can be written in if-then form. Okay, we use some symbols here. We're going to talk a little bit about P and then Q, and that arrow means that we can read it kind of two ways. If P, then Q, or you can read it as P implies Q. Okay? Whenever we make a conditional statement, we have a hypothesis. And this is going to be the phrase immediately that follows if, and then the conclusion, which is the phrase that immediately follows then. All right, and we use the P to represent the hypothesis and the Q to represent the conclusion. Now, negation is going the other direction, right, or thinking opposite here, and we use the sign that's called a tilde, right, so it's this symbol here, all right, and so if I were to put a P there, that would be not P, all right, and we're going to get into that a little bit later about how we can use that. All right, let's do a couple of examples with these conditional statements. Okay, so this first one says, if you live in Nashville, then you live in Tennessee. So the hypothesis is that you live in Nashville. And the conclusion is that you live in Tennessee. Okay? The next one, all right, this is something we just talked about in our previous unit, right at the end of it. If the sum of the measures of two angles is 90 degrees, then they are complementary angles. So the hypothesis is that the sum of the measures of two angles is 90 degrees. And the conclusion, we write they are complementary angles. Okay, so that's kind of how we break it up in terms of conditional statements. All right, and if you in the homework, I'm going to ask you to write some of these statements as conditional statements, and just make sure you remember to use the if then. Right, both of these had them. All right, but you got to make sure when you write statements as conditional statements, we got to use if then statements. Okay, let's go to a couple of other vocab words that you're going to need to know. All right, so this is, the three ones are inverse, converse, and contrapositive. All right, and again, a lot of this stuff is in your textbook, so you can always refer to it while you're doing your homework. Just flip back a couple of pages. You can find all these vocab words. So the inverse, all right, this is formed by using that negation, so negating the hypothesis and the conclusion. All right, so essentially, we're going to write if not P, then not Q, right? Because we got to negate both. So put not in front of both of the letters. So we're going to use not P implies not Q. For the converse, this is when you switch or exchange the hypothesis and conclusion. All right, so they trade places. So for symbols, we're going to be Q implies P. All right, or we're going to say if Q, then P. So they trade places. And the contrapositive is doing both of these things. So it's negating and switching the hypothesis and the conclusion. So you do both. So this one, for the contrapositive, we're going to write not Q implies not P. All right, or if not Q, then not P. All right, and again, let your brain kind of work through this. It'll take some time to focus on this or to kind of make sure you understand it, but keep trying, okay? Keep looking at your examples. All right, let's do an example, okay? So this example 2 says, we're going to consider this conditional statement. If you are a guitar player, then you are a musician. So P is the hypothesis. I'm going to go ahead and highlight right here. So you are a guitar player. That is going to be our P. All right, and then after the then part, you are a musician, is going to be our conclusion, or Q. Okay, write each statement in words, so the converse, the inverse, and the contrapositive, then describe whether it is true or false. So converse, this first one, you'll notice that they're trading places. So I'm going to write, if you are a musician, then you are a guitar player. Okay, so that those traded places, let's think about this. If you are a musician, then you are a guitar player. Well, you don't actually have to be a guitar player if you are a musician, right? You can be a musician and play something other things besides the guitar. So this I'm going to categorize as a false statement. Okay, let's do the inverse. Okay, so going back to the P then Q, but we've got to do not in front of each of them. So if you are not a guitar player, then you are not a musician. Okay, so thinking about this one, right? If you're not a guitar player, then you're not a musician. Again, you can still be a musician even if you are not a guitar player. So this is also, like the previous one, going to be false. And now the last one, this is where we do the negating and the switching. All right, so we're going to do, if you are not a musician, then you are not a guitar player. Okay, so that was the last one here for the contrapositive. So let's think about this one. If you're not a musician, then you are not a guitar player. So this is actually true because a person who is not a musician cannot be a guitar player. So this one I'm going to write true. All right, so that's an example of writing those different conditional statements, or one conditional statement using the converse, the inverse, and the contrapositive. Okay, let's go to biconditional statements. So biconditional statements, right? These, essentially what I'm looking for here is if both your conditional, so like that first conditional statement, and the converse statement, like that thing we just talked about up here, the converse, if you switch the order or the direction, if they're both true, then this is called a biconditional statement. All right, so this is a statement that contains the phrase, all right, I'll put it right here in terms of the reading it as, is P if and only if Q. Okay? So again, the idea here is that you're looking for that phrase if and only if. If it has that phrase, that's a biconditional statement. So the symbolic form we use to show that both the converse and the conditional statement are true, right? The idea is like, okay, so P, then Q is true, and then Q, then P is Q. Let me try that again. If P, then Q, and if Q, then P. If both of those are true, then we can just write P and Q, but we put an arrow going both directions. All right, so P if and only if Q. That's a biconditional statement. So let's do an example with this definition. All right, if two lines intersect to form a right angle, then they are perpendicular lines. So I'm going to go ahead and let P be this first part here. Two lines intersect to form a right angle, so that's P. And then I'm going to do they are perpendicular lines as Q. Okay, so we're saying P implies Q. Now I'm going to do the converse of this. Right, remember that's Q implies P. So if two lines are perpendicular lines, then they intersect to form a right angle. Okay, and if you read this statement, you can see the statement is also true. All right, so because the conditional statement was true and because the converse is true, this is what we call a biconditional statement. So I can write this definition using the if and only if phrase. So I'm going to go back to my P and Q. Right, so the idea is I'm about to write P if and only if Q, okay? So two lines intersect to form a right angle if and only if they are perpendicular lines. Okay, so that's it for the stuff I wanted to cover. I'm gonna finish the video now, but I will have a key that has the rest of these statements if you wanted to check them out, looking at the key. But ultimately, check out that homework. Come see me if you have questions about these. Good luck.